All right, here is another video on homework 5. This is bonus, but I wanted to kind of show you to help you. So problem 1 is you have a semicircle 40-foot diameter tunnel is to be built under a 150-foot deep, 850-foot long lake. Determine the total hydrostatic force acting on the roof of the tunnel. So first step you need to do is you only need to isolate the section above the curved section, which is this dotted line, dotted section here. I redrew it over here. All right, so we have the top surface, which is FY, which is black. We also have the sides, which are FX1 and FX2. Then you have the hydrostatic force component, which is FV and FH. That's the curved part. And then you have the weights. On the left side, W1, and on the right side, W2. That's the weights of the water that are cut in half. Okay, so what you can do is you sum the forces in the X, you sum the forces in the Y. And you'll notice that FH is 0, but the V component of the curve is a component of the hydrostatic force at the top surface plus the two weights from our free body diagram. So you can now plug and chug using P average and area and all that stuff, rho GH. Okay. Then problem 2, this is a very good problem. Basically, you have a circular gate of radius 3. The gate controls the water level. You want to find the minimum spring force required to keep the gate closed when it rises to the top level. Okay, so what you need to do is you do a free body diagram on the water along the curve, which is only pretty much this section right here. Okay. So you have, like, this is in and out of the page, right? We did a dotted. Okay. It would look something like this. The FX is that left face. The bottom section is FY. And then you have the curved part, which is FR. Okay. So you can do the free body diagram on the water, which you can then find your FH and FV. And then what you need to do is you need to do a free body diagram on the gate because it's hinged at A. You have FR, and you notice that FR here and here, they're equal and opposite. The left is the free body diagram of the water. The right is the free body diagram of the gate. And then you can sum the moment at A. All right, and I'm not going to show you because you can go ahead and do it now. So these two terms would go, and so you're left with this term and this term in the equation. Okay. All right. Now, it's tricky to find the distances. So what you could do is, I believe I have a AutoCAD file for you if you want to open that up and find the distances, the perpendicular distances, right? From this point and that point. You know that one because that's 3 meters. Tricky one is FR. I want you to try it though. But this will help you get started on this homework problem. Again, this is bonus. Thank you. Good luck and ask questions.